In this video, we are going to see calculus of complex functions. Basically, the review of a function of a complex variable, and we'll discuss about its limit, continuity, and differentiability. And then, what do you mean by analytical functions? And Cauchy-Riemann equations in Cartesian and polar forms, and consequences, construction of analytical functions by using Milne-Thomson method. These are the things that's there in module 1. First, let's see the basics. What do you know about a complex number? Okay, I can write z as x plus iy, where x is the real part, y is the imaginary part. This is Cartesian form. Same thing if I say in polar form, what you will say? R cos theta plus I r sin theta. R is common. So this is in polar form. And modulus of z, what we will do? We will take square root of real part the whole square plus imaginary part the whole square. That we will call it as r. And then amplitude. Amplitude, what is that? Tan inverse of I by x, that is theta. This we have learnt. And another important thing is complex conjugate. If it is x plus iy, I will change the sign. I will write it as x minus iy. So this is the complex conjugate of z, and we will denote it as z bar. Correct? And then we have these formulas, that is e power I theta is cos theta plus I sin theta, and e power minus I theta is cos theta minus I sin theta. From these two basics, and if we add, I will get this equation formula: e power I theta plus e power minus I theta by 2 is equal to cos theta. And if I subtract, I will get e power I theta minus e power minus I theta by 2I is equal to sin theta. Okay, these are all the basic concepts and formulas that you have studied in complex. And cos of I theta is equal to cos h theta. H is nothing but hyperbolic. Sin of I theta is I sin h theta. We will be using these things in the problems. Okay, that is why I am just revising the basic concepts. And finally, we have De Moivre's theorem, that is cos theta plus I sin theta the whole power n is cos n theta plus I sin n theta per n is real. These are the things that you have learnt already. Now what we are going to learn? We are going to learn about function of a complex variable. Okay. So far we know function of a y is equal to f of x. We will write. Okay. So here x is a real variable. Here we have y is equal to f of z, where z is nothing but complex. So it's called a function of a complex variable z, and it can be single valued or multi-valued according as, like, given z corresponds to one or more value of z. Okay, and see the notation: w is equal to f of z is equal to u of x comma y plus I into v of x comma y. This is in Cartesian form. So this is the real part, u is the real part and v is the imaginary part. Similarly, we have polar form also. W is equal to, w is equal to f of z is equal to u of r comma theta plus I into v of r comma theta. This is the polar form. So now we are going to discuss about limit, continuity and differentiation of a complex function. Okay, this is more or less same as the real function. Let's see that definition. And also, if any given function, that is say f of z is equal to z square, you should know how to find the real value and imaginary value. See, the function is z square. Z is nothing but x plus iy the whole square. We are squaring it. A plus b the whole square formula, x square plus 2x iy plus I square y square. We know I square value is minus 1. So, x square is a real part and minus y square is also a real part. We have written it together. Plus I into 2xy. This is the imaginary part. So what is u? U is x square minus y square and v is 2xy. This is in Cartesian form. If they ask the same question in polar form, in the place of z, what you will substitute? R e power I theta. Remember, in Cartesian form, we will substitute z as x plus iy. In polar form, we substitute z as r e power I theta. So we have r e power I theta the whole square, which I can write it as r square into e power 2I theta. Already we have seen what is the formula for e power I theta, cos theta plus I sin theta. Here we have e power I 2 theta. So we have cos 2 theta plus I sin 2 theta. So what is the real part? R square cos 2 theta is the real part and r square sin 2 theta is the imaginary part. Similarly, for each function, we can find out the real part as well as imaginary part in both the forms, that is in Cartesian as well as in polar form. And now sometimes there are problems where Cartesian form will be easier, sometimes polar form will be easier. If you see this problem log z, here if I write logs of x plus iy, it's tough for us to split it, correct? So if they give such problems, then you have to shift the problem to polar form and it's easy for you. Because z is equal to r e power I theta, if you substitute it's in multiplication, because log m into log n, you can write it as log m plus log n. So log r plus log of e power I theta. Okay, so e power I theta is nothing but, yeah, we have log r plus log of e power I theta. The power log m power n is nothing but n log m. Power will come down. Log r plus I theta into log e. Log e, we are taking a natural log, so log e to the base e is 1. So now it is easy for us. U plus iv is equal to log r plus I theta. So real part u is equal to log r and imaginary part v is equal to theta. So in such problems, only polar form helps you. So when you are going to solve a problem, just see whether you can solve it by Cartesian or polar. Okay, and then you can go for it. Some problems you can solve by both methods. That's not a problem. Now coming to the concept of limit. Okay, now you see here a complex valued function f of x defined in the neighborhood of a point z0 is said to have limit L as z tends to z0 if for every epsilon greater than 0 a small there exists a positive real number delta such that modulus of f of z minus L less than epsilon when modulus of z minus z0 less than delta. Okay, this is written as limit z tends to z0 f of z is equal to L. So we will be wondering what is this. So what do you mean by neighborhood? What do you mean by modulus? See, the value z is in one domain and f of z is in another domain. So if I say for every epsilon greater than 0, there exists a positive real number delta. Okay, so this epsilon is there in the codomain and this is there in the domain z minus z0 less than delta. And whenever I say this neighborhood, this is nothing but a circle. That is, if I say modulus of z minus z0, replace z by x plus iy, z0 is some point x0 y0. Now you can segregate real value. X minus x0 is real value, I have written here, plus I into y minus y0 is imaginary value. What is modulus? Root of real square plus imaginary square. So if I square on both sides, it's nothing but a circle with center x0 y0. So whenever I say neighborhood or modulus of z minus z0, so it is nothing but a circle. So it means for every point in the z plane within that neighborhood, there corresponds a point in f of z plane. That's it. This is a simple version of limit. Similarly, for continuity, a complex valued function f of z is said to be continuous at z is equal to z0 if f of z0 exists. There should be a point there in the codomain and limit z tends to z0 f of z is equal to f of z0. These definitions will look similar to the real function, but when you are applying the limit, as I told you in the introduction, the limit may approach either through real, through imaginary, or through a straight line or through a circle, etc. So there in real, it will be either through real or imaginary, correct? So this is the only difference, but the basic definitions are almost similar. Now coming to the concept of differentiability. A complex valued function is said to be differentiable at z0 if limit z tends to z0 f of z minus f of z0 by z minus z0 exists and it is unique. Okay, this limit when exists, it's called the derivative of f of z at that particular point z is equal to z0 and we denote it by f dash of z0. This is same as the definition of real function. Okay, so we can write this as f dash of z0 is equal to limit delta z tends to 0 f of z0 plus z minus f of z0 by delta z. If we rewrite z minus z0 as delta z, so this and this are one and the same. Okay, and finally coming to our definition of analytical functions. This is from here only your questions will start. A complex valued function w is equal to f of z is said to be analytic if dw by dz is equal to f dash of z, that's equal to limit delta z tends to 0, f of z plus delta z minus f of z by delta z exists and is unique at z naught in the neighborhood of z naught. It means this is the same as the derivative definition. So I am saying that this derivative should exist and it should be unique at the point z naught and in the neighborhood of z naught. Okay. Further, it is said to be analytical in the region if it is analytic at every point of the region. So I am saying analytic at z naught means the derivative should exist and unique at z naught. Okay, and in the neighborhood of z naught. Now you know what do you mean by neighborhood of z naught, correct? Further, if I say analytic in the entire region, it means if it is analytic at every point in the region. So we call analytic function as regular function or holomorphic function. So in the problems they may ask you to prove that it's an analytical function or a holomorphic function or a regular function. Whichever way they call, we can solve it by the same method. Okay. Now coming to the Cauchy-Riemann equations in Cartesian form. So in your syllabus we have CR equations in Cartesian form as well as in polar form, and one question will be there by default in all the V2 question papers. And they will ask you to state and prove. So you have to write the statement and you have to prove it. Okay. So in the next video, let's state and prove CR equations in Cartesian form. Thank you.